What's happening, dogs? Mr. Allen here, solving a couple trig equations using the unit circle in this video. So let's get after it with the first one. I got 4 times sine squared theta minus 3 equals 0. How the heck do I solve that? Well, I got to get sine of theta by itself. So first step, let's add 3 to both sides. I got 4 times sine squared theta equals 3. Then I'll divide by 4. So I got sine squared theta equals 3/4. But how do I get rid of that squared? Got a square root on both sides. So your Algebra 1 skills kind of come in handy here, guys. So make sure you don't forget how to solve basic equations because you're going to use that forever. Not in the real world necessarily, but like in your math world. You're definitely going to use it in your math world. So let's see. I got the square root of 3. I can't do that. It's just square root of 3. I can't simplify that. Square root of 4 is 2, though. And don't forget that you got your plus or minus. So plus or minus root 3 over 2. Okay. So where's sine of theta going to be root 3 over 2? So what theta value will make that happen? Let's start with the positive root 3 over 2 and just look at our first quadrant, right? I like to look at my first quadrant and then I place it elsewhere as needed. Well, sine is my y-coordinate, and up at pi over 3, I've got the root 3 over 2. That means that pi over 3 is going to be one of my answers. So let's jot that down, pi over 3. Boom. But there are others, right? It's actually where it's positive and it's negative. So not only am I going to be in the second quadrant, I'm also going to be in the third and fourth where sine is negative. So we got to just basically get all of our pi over 3 reference, or all of our pi over 3 radian measures around the unit circle. The other one is over here, which is 2 pi over 3. Then down here, it's, more like this right here, it's 4 pi over 3. And then the last one I'm going to have to jot up here is down here, which is 5 pi over 3. So those are my 4 solutions. Sorry for going up there. I ran out of room. My unit circle got in the way, but I definitely like jotting down the unit circle if I'm going to solve it that way, but I only write down my first quadrant and then I position it accordingly into the others because otherwise it's a lot of writing, you know? And all I'm really deciding is if it's positive or negative. So there's my 4 solutions for this one. Plus or minus root 3 over 2 for sine. Bibbidi boppity. All right, next one here we got cosine. Okay, so similar start to this one, it seems, right? I'm going to add 4, okay? And then I got 4 cosine squared theta equals 4. And then when I divide by 4, I get cosine squared theta equals 1. And if I square root on both sides, I'll get cosine of theta equals plus or minus 1. Don't forget about that plus or minus when solving with square roots. Common thing to forget, you know, when you're solving in Algebra 1, and it comes back here in Algebra 2 or pre-calc, depending on what class you're in. So where is cosine going to equal 1? Well, now I'm looking at my quadrantals here, right? So where is cosine positive 1? It's my x-coordinate. It's over here at 0. So 0 is one of my solutions. We'll do that in pink, 0. Where else is cosine 1? Nowhere else. Not at 2 pi because we're not including 2 pi. It does equal 1 at 2 pi, but that's actually why you write the domain restriction in that way, where it's equal to 0, but not equal to 2 pi, because it would essentially be redundant. I'd be using the same point twice. So that's why it is written that way. So we would not say 2 pi here, because it's not within the domain. But what about negative 1? Well, cosine is negative 1 over here at pi. So those are my 2 solutions. Only 2 for this one, but 4 for the previous one. All right, there you go, guys. So we got some solving with square roots with our trig functions. It's pretty dope and awesome. Thank you guys for watching. If you have any questions or requests for videos, pop them in the comments or just say what up. I'll say what up back. See you guys later. Have a wonderful day.